Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillah ar-Rahman ar-Rahim. I think this is where we stopped last time. We are done with talking about the density of the histogram, right? And we talked about what the horizontal axis means and what the vertical axis means, right? So can you remind me what is the horizontal axis and what's the vertical axis? Is what? The horizontal or vertical? The vertical is density. What's the horizontal? The numerical variable. Okay, so one of the numerical variables, and the y-axis is the density. Okay, and if I want to see the percentage, then what indicates percentage in histograms? The area of the yeah. So the area of the bar is the percentage. Okay, the height is the density, which is the percentage over what? Over the size of the bin. Okay, over the size of the bin. So here is a quick comparison of bar chart and versus histograms. So both, of course, display distributions, but bar chart displays the distribution of a categorical variable, while the histogram displays the distribution of what? Of a numerical variable. The bars in the bar chart have equal width, okay, but that's different from different in the histogram. The bins can be unequal, and also the horizontal axis is to scale because it represents a numerical variable. Okay, and the height of the bars in the bar chart indicates the count, which is proportional to the percentage of the individuals within that category. But in the histogram, the height is different from, of course, the area. Okay, or the meaning of them is different. The height in the histogram, the heights of the bars, indicate the density, but the area indicates the percentage. Okay, so that's the summary of what we went through last time. Here is a discussion question for you, just to revise what we covered. If you are given this data table, we have two columns. We have the name and we have the income. It seems like these are, I think, NBA players, and for each player we have his income in millions in a year. Now, if I asked you what is the height of each bar in this histogram, if I want to draw a histogram for this table, what will be the height of each bar? So look at this this command, which will plot eventually a histogram, right? What are the bins that we have? So what are we plotting before the bins? What are we plotting here? A histogram. Okay, what is the numerical variable that we are plotting? The income, right? Why is that? Because this is one, right? This is the index of the column. So we can give the name of the column or the index of the column. So we are looking at the distribution of the income now. Okay. Now what are the bins? So I cannot say the bins are 0, 15, 25, 85, right? These are not the bins. These are just a representation of the bins. But the bin is, each bin is an interval, right? So what are the intervals? From 0 to 15, 15 to 25, 25 to 85. So we have 3 bins here. Okay, now let's look at the first bin and tell me, maybe a minute, and tell me what will be the height of the bar of this bin. So the first bin here is from 0 to 15, right? So the height will be 15. How did you get it? Can you think about it for a second? The height of the bar in the histogram. You can talk together if you want. Check how you actually compute the height in this case. Okay, so do it. What will be the height? Tell me at least the two numbers. We divide this by that. Question. Do it. You have all the data here. And these are 20, if you don't want to count the number of rows here. The number of rows here is 20. 20. 20 player. What? Huh? Yes, that's what I'm asking for. 4. So you said earlier 15, right? Now it's 4. 4? 12. Okay, is that a third answer or second answer? Okay, 12. Okay, why is it 12? We have 12 income between 0 to 15. Okay. Is that true? How many? Okay, so how do we count? How do we get the height? How do we get the height? Can you tell me? Divide the income. Okay, percentage of the individuals in that bin over the size of the bin, right? Okay, now let's get this the percentage of the population or the individuals within that bin. What is the percentage? Is the number of individuals, right? The number of rows within that bin divided by 20, which is the total number of rows. How many rows here belong to the bin, to the first bin? 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Why is it 9? 9, okay. Why not 12? You said 12, right? Yes, 15 is excluded, right? So the number of individuals here in that bin is 9. So the percentage is 9 over 20, which is 0.45, right? Of course, so the percentage is 45%, divided by what is the bin size here? 15. Okay, so it's 0.45 divided by 15. So this is 45% divided by 15. So that will be 3% per million. Okay, so that's the height, which is density. Okay, so did you understand how we got it? Yes, the last part. So we got this, right? Which is 12 over 20. Now, you remember the density, we divide the percentage by the bin size. The bin here is from 0 to 15, right? So the bin size is 15. So we divide by 15, will give us 3% per million. So this is not 3%. That's 3% per million. Okay, that's the right unit. And of course, you can do the same for the two other bins. Okay, any question about how it's calculated? Okay, I think it's clear now. You know now why it's not 12? Why it's not 15? Why it's not 4? Okay. This is just an overview of the four types of plots that we covered so far in the visualization session. We studied scatter plot, which is a relation between two numerical variables, line graph, which is still also a relation between two numerical variables, but one of them, which is represented on the x-axis, usually it is sequential, like time. The third one is bar chart, which is displaying the distribution of a categorical variable, and the histogram, which is representing the distribution of a numerical variable. There is a demo that is something like a review of the visualization part. Please go over it yourself. Okay, so I will leave that to you, and it is one of the notebooks that are associated with this session. It's already on Blackboard. Now, the last question in the visualization session is a discussion question. I want you to think about it. Given that we have data about daily temperatures, so here we have a table. In each row, we have the high and low temperature for a given day. We also have the sky condition. Okay, so the first day, the high temperature was 55.1, the low was 43.7, and it was cloudy. Okay, and so on. So we are getting these measurements over about 365 days, which is over a year. Okay, so this is the data that we have. Now the question is, which type of chart would you use to answer each of the following questions? Okay, the first question is, are there more cloudy than sunny days? So which type of chart can help me answer this question? Bar chart. Why is that?
Because we need a categorical chart to get the number of days that it's cloudy.
Okay, so the variable that of concern here is categorical or numerical? Category, which is the sky condition, right? And we want to get how many, if there is more cloudy days than sunny days, right? So we are interested in counting or percentages? In counts, right? We are interested in counts here. So counts and categorical, so it seems like a bar chart will be the best here. Okay, any question about that? So that was easy. How about this one? What percentage of days have a high temperature above 72? What percentage of days have a high above 72? Why is it histogram? Because it's percentage. Any percentage, then it will be a histogram. Think about it for a second. Okay? Think about it. What do we have and what do we need to answer this question? So if we set a histogram, what should we determine to plot the histogram? We need to know what should be on the x-axis, right? First, right? So what will be in the x-axis in a histogram? Huh? The bins, right? The bins. The bins of a numerical variable, right? So do you have a numerical variable here? What is the numerical variable? The high temperature, right? Okay, so the high temperature, we need to know what percentage of days above 72%, right? So what should be the bins here?
One of them should be from 72.
Yes, from 72 and above, right? And how about the others? Below, right? So we just need maybe 2 bins. We don't need more than 2 bins here, right? One that is below 72 and the other is 72 and above, right? Okay, now when we do that, what will be on the y-axis? The density, right? But the area of the each bar will give us the percentage that we need. Okay? So the histogram is correct, but I want you really to think about the details. Any question about that? Okay. Now the third and last one. Did many days have a difference of more than 20 degrees between their high and low temperatures? You can discuss together, by the way. I want you to think together. What should we use here? Think for a second, please. Same like the previous one? Exactly? Exactly? Okay, when you say histogram, don't just tell me histogram. Tell me how are you plotted. What is the variable, what are the bins, and so on. Are you ready? Okay. Okay, so do we have this in the data set? We don't have this. So we have to calculate it first, right? So we have to add a new column probably to that table that will indicate the difference in the temperature, right? Do we need the absolute? Of course, the high will be more bigger than low. So probably we don't need the absolute here. So it's just the difference between high and low. So now we'll add it as a column to the table. Now this will be the variable that we will plot, right? Okay. what is above 20 degrees? The difference column, right? The difference value. Okay, so let's call the variable difference. So difference is less than 20 and more than, less than or equal to 20 and more than 20. Okay, now, if we do that, then what are we plotting? I understand. I mean, on the y-axis, what will be the meaning of the y-axis here? So how can we answer this question? Can we directly answer this question? How many days did many days have a difference of more than 20 degrees? So it seems like we need the count, right? So we need the count of the days, the number of days that have a difference of 20 or more, right? How can we get that from the histogram? Can we get the count from the histogram? Is it possible? No. Why not?
Because the Histogram gives us the percentage of days.
Very good. So if I told you that the percentage is 40%, 40% of what? 40% of the year, which is 40% of the days, right? Can I get the number of days if I told you that? No?
Yes.
If I told you 40% of the days, you cannot get the number of days? How can you get the number of days? Just multiply this percentage by...
But he didn't want the number of days.
Good. Okay, so he didn't want the number of days, but he asked it, did many days have a difference or more? So to understand whether this is many or not, you need to know the count probably. Okay, because maybe the percent is high, but the count is really low. Okay, so it depends on the individuals that you are looking at, which are the days. So we can get the percentage. We can get also from the percentage, of course, we can get the count. Okay, now looking at the count, we can decide whether this is many or not. Okay, so this is subjective here, but of course it shouldn't be 2 or 3 days. Maybe at least tens of days, probably. Yes. You just approximate, of course, round. Just round, of course. Okay, any other questions? So is that clear now? I think with these discussion questions, it should be clear when should we use bar charts and when should we use histograms, and also when should we use the line plots and the scatter plots that we discussed earlier. Okay, with that, we are done with the visualization part or session, and we will move on to a new session, which is the 6th session. Okay, so this is section number 6 now. Do you see that? Okay. This is session number 6. We are done with 5 sessions already. So let's see what we covered so far in the course. What are the sessions that we covered in the course so far? So the first one was just an introduction, a very brief introduction to maybe notebooks and also brief introduction to data science. Then causality and associations. Okay. Then we went through a quick introduction to Python. Of course, you realize now that we are not giving a course about Python, right? It's just an introduction to Python in the context of data science, the things from Python that we need to do what we have done, which is exploratory work so far. So the third session was about Python. The fourth one, tables. Okay, so it was an introduction to tables. And the fifth one was the visualization one. Okay, now we will talk more about tables, but with more focus on functions. How can we do some computations out of the tables? How can we apply some computations to the tables, to the rows and columns? And that will give us some summaries of the table that we can look at to get more insights from the data sets that we are dealing with. So how functions are defined in Python? Here is a quick look about how functions, what the syntax is of functions. So we write first the word diff, so that's a reserved word. Then the name of the function, Okay, that's usual, right? So, and then the list of arguments of the function. Notice that there is a colon here. And then the body of the function. The body, of course, can have multiple lines. I don't know if you noticed so far or not. Maybe not, because we didn't have long functions. But you should pay attention to how the indentation is done in Python, or what's the importance of indentation here. Okay, you notice that we don't have braces here. Okay, so the body of the function has to be all aligned. So the indentation here is defining the scope of the code that you write. So this is the function. What are we doing here? We are actually getting the difference between the min and max of values, but that's not of interest to us. So here's that's the syntax, and it's very simple. Diff, function name, arguments, colon, and then you write the body of the function. And of course, if the function is returning a value, you use the return statement. So that's the return expression. So you can give a value or an expression that will evaluate to a value eventually. So here is a demo about functions, and you see really a nice thing that probably you didn't see before. So let's go through this. So this is a function that takes an argument and multiplies it with 3. That's a very simple function, right? Okay, so let's call it with the number 3. Of course, we will get 9. We can call it with a variable. Okay, so num is 4 here, so we'll get 12. We can call it with an expression. Yes. Okay, so that's the definition of the function. So x here is an argument, and we call the function with the values of the argument. But that's like the argument of the function, right? You don't give, you get a value, right? So I'm assuming that you understand that thing from programming already. That this is the definition of the function. We didn't call the function yet. Okay, so x is an argument or a parameter of that function. Okay, so when you call the function, you give it a value. It's like when you say in mathematics, f of x equal x squared. So did you give a value for x? Okay. Okay. So that was that's what was confusing. Fine. Okay. So we gave it, of course, 3 here. We give it here a variable, which is the value of the variable. So it would be 4. Then the return value is 12. Here, what should be the value? The return value? Huh? So what will be the returned value? 20. So that's the value of the parameter is 20. Okay, and of course that will be the value of x multiplied by 3 will be 60. Okay, so far that's very similar to, of course, what we know already about functions in programming. Right? Any question up to this point? Okay. Now look at this. Can we do this? Why? Okay. Notice that in Python, variables don't have type. Okay? So if that operation can be done on that variable, it will be done. Okay? So we don't have to say here string or integer or anything. It's just multiplying 3 by that variable, whatever that variable is. Okay? So the output or the return value of this will be the repetition of the input 3 times if it's a string. Okay, so you see here the beauty of Python here. We didn't need to actually define different functions with different types of input of arguments. If we were in Java, I think we should have defined 3 functions: one for integers, one for strings, and one for the third reason, for third types here, which we didn't discuss yet. So look at this. What is this? What's the input here? It's an array. Okay, so if we wanted even to do it for an array, we have to define it in Java, of course, explicitly. What will be the output here?
To multiply each element in the array by 3.
Yes, so that's the definition of multiplying an array by a number, right? So when we multiply an array by a number, each element in the array, are you with us? Okay, each element in the array will be multiplied by 3. So what should be the return in the array here?
0,
What's the input array?
0, 0,
0, 1, 2, 3. Okay, so the returned array will be 0, 3, 6, 9. Okay, multiplying by 3. Okay, any questions so far? Okay, of course, functions also can take more than one argument. Okay, so if I want to compute the hypotenuse of a right-angled triangle, then I give the length of two sides, I get the hypotenuse. So the function here takes x and y, which is this equation. Of course, I think you are familiar with that. Getting x and y, I compute h to be the square root of x squared plus y squared. So we take the square root of x plus square root of y, and then we take the root of it, okay, returning the value of the length of that side. Okay, so that's an example of a function that takes two arguments. I can call it, of course, with two arguments, 9 and 12, will give us 15. 2 will give us 2.8. One thing that is not here, but it is in the textbook, which is that, and we saw it actually before, that sometimes we can call the function with one argument, or two arguments, or three arguments, and so on, right? You saw that before, right? How do we do that? How can we do dynamic number of arguments like that? Okay, so it is done by giving default values for the parameters that are missing. Okay, so I can say here, of course that might not be in context, but just as an example, I can say y equal 1 in the definition of the function. So if you just give me x, if I said y equal 1, that means that the default value of y is 1, which means that if the caller didn't give a value for y, the value of y will be 1. So the caller doesn't have to actually assign a value for that argument. Okay, so he or she can give only one argument, which is x, and the other one, if it's missing, it will be 1. If it's not missing, of course, it will get the value that is used in the call. Okay, and we saw that before. For example, in the previous lecture, we mentioned the normalized parameter of the histogram, right? Normed. We said that when it's false, then we will not get a histogram, right? We'll get just the counts. So the default value is 2. When we don't give the normed the value for that argument, it is 2. So it will be we will get a histogram. But if we give it false, we'll get just the counts. So you will see that in the textbook. Yes.
What are the default values for the maximum function in NumPy 5?
Okay, of course I don't remember everything. You should check the documentation to see. That has what?
That has multiple parameters?
No, it's not. Okay, that's this one in particular is not by default values. It takes a list of things. So it's not it doesn't have multiple parameters. Actually, it has one parameter, but it's a list of values. Okay, we didn't see an example. We didn't talk about how to do that yet. Okay, but that's different from defining default values.
So can we define, for example, our max function?
We didn't cover it yet in the course how to define it. Okay, but of course you can do something like that. Yes. Okay, but the idea is to take a list of arguments, not just, and the list can be of any length, and you define your function over the values in the list. Okay. Okay. Now let's get back to the slides. Look at this function and tell me what does it do. So what does this function do? What kind of input does it take what output will it give, and what's a reasonable name for that function? What are we doing here? So it takes an array. How did you know? Okay, there's sum here. Okay, so it seems like this is sum of a list of values, so probably S is an array. Okay, so that's the type of the input. Type, what are we doing here? What's the meaning of this function? Okay, it seems like you are affected by what we just covered. Okay, so it's not the density, it's simpler than that. It's what? Look at what we're doing here. It's not the average. Where is the average? When we divide by the sum and multiply by 100, what are we doing? Getting the percentage. Okay, getting the percentage. It's not the average. Percentage is not an average, right? Okay, but you said average. Okay, so you are okay. I didn't hear the percentage. Okay, so yes, it's the percentage of what? Each element. So the returned value is what? Is an array. Okay, so the input is an array and the returned value is an array. Each element in the output is the percentage of the corresponding element in the input array. Yeah, this 2 is just the number of decimal points for rounding. Okay, is that clear now? So maybe you can give it a name like percentage or something like that. Okay, let's see here this function. So here we give it a name percent of total, and that's the definition that we just saw. So if I give it that input, what should I get back? I understand it's an array. What are the values in that array?
0%, 0.20, 0.50, and 0.50.
Yes, so 0.1, 0.2, 0.3, 0.4, which are the percentages. Or actually, will we get 0.1 or we get 10? Look at the definition of the function. 10, right? So we'll get 10, 20, 30, 40, which is the percentages. Okay, so that's the percentages. And here's another example. We have just 3 elements here, 1, 213, and 38. So we'll see that the most of the percentage will be here. Okay, so this is just an example of another function. Any questions? Everything is simple so far? Okay. Now let's get back and see another and study another very important function, which is apply. So have you heard about apply before? Okay. So the apply function, it's a function that is applied to an array, which means that it is applied to every element in the array, which means that it will return back an array of values. Okay. No, it doesn't. It gives you a new array. Okay, so it is applied to an array. So that function will be applied or will be called by every element in the array. Of course, when it's called by each element, it will give us a new value, okay, which will be in another array also for each of the input values. Okay, we'll see an example very soon. So the first argument of that function, the function apply, is the function that I want to apply. So apply takes a function to apply. Okay, so the first argument of the apply function is the function that I want to apply, and the other arguments is the input column. So it is applied on the table structure that we used to work on, and if it's just one column, then it will go through every element in the column and apply that function, the given function, to it. So this is the signature of the apply function. So it is applied on a table. We give it the function name and the column label. Okay? So let's see how we can use it. Here is a here is a table that has how many columns here? 4 columns. 2 columns. Any 3 columns? Okay, is it 2 or 4? 2 columns, right? We have the person, and this is the values in the person column, and birth year, and this is the values of the birth year. And then we will define a function called cap at 1980. What does it do? It doesn't seem it takes an array, right? It's min. X doesn't have to be an array, right? It can be a value. Let's be simple. Okay, so it takes a value, and which is x, and compare it with 1980. If that value is less than 1980, what will be returned? The value. If not, it will return 1980. So that's why it's called cap at 1980. So any value that you give me, I will give it as maximum 1980. If it's less than 1980, I will pass it. If it's more than 1980, I will just return 1980. Okay? Clear? Now, if I call it with 1975, what would be the value? The returned value? 1975. If I call it with 1991? 1980. Good. Okay. Now, I will apply it on the birth year column of the table. How is that? I use, of course, ages is the name of the table. Dot apply. Okay, remember, it takes a function, and now we indicate the function by its name. So the functions actually in Python are just variables. You can use the names of the variables. Okay, so apply, and then the name of the function, which is cap at 1980, and then what's this? That's the column I want to apply this function to. Okay, now what will be the returned value of this call? Yes. A new column? No, we said that it takes a column but returns an array. Okay? It actually adds a column. Let me. No, I don't think it adds. I don't think it adds a column. It returns an array. Okay? It returns an array. But what will be the values of the arrays of the array? Yeah. Tell me what are the values given this data set. Yes. Okay, so 1980 for the first two, and the same values for the other. So that's what we get here. So 1980 for the first two, and 67 and 04 for the other one. Okay. Did you understand how it was executed? No.
I did, but what is the purpose of using it? It's like calling the function in a very normal way.
Okay. The purpose is the ease of doing it, that we just call it for every element. We don't need to do a loop, for example, to call it. Okay? We just give the name, give the function, and it will be applied for everything on the table, on that column.
So we cannot call the function and then just pass the birth year as a parameter?
You have to design it that way then. Okay, but remember, we didn't have to design it that way here. We just designed it to take just one value. Okay, so here the function is called how many times? So that's a good question. How many times the function is called here? The function cap at 1980, how many times it is called? 4 times. Okay, but the function itself is very simple. It takes just one number. Okay, but in what you thought about, the function will be called once, but over one array. Okay, so it's just an ease of use, and we will see another nice thing about apply very soon.
We can use it for searching also, right?
No, apply. You apply a function, whatever the function is. Okay, so it depends on what you are doing. Okay, now look at this function. This function, so cap at 1980 takes one argument only, right? Okay, and it makes sense that it will be applied on one column because it takes one argument only, right? So the argument will be each element in that column, right? Are you following with me, Fatma? Amina, sorry. Okay. Now, here is a function that takes two arguments. It takes a name and a year, and it calculates the age. Seems like a name and the year of the birth year of a person. So it calculates the age of the person, and then it returns what? What's the type of the returned variable here? Value? String. The name is then the age of that person. Okay? Now I want to apply this function on the ages table. How can I do that? I want to apply this function on the table so that for every person I get this message, this string.
So just change the color.
Yes.
Ages
Ages
don't apply.
don't apply.
And then the name and age we need to call.
Name and age, that's the name of the function.
And then we need to pass the person, column, and the birthday.
Very good. So we need to pass here two columns, not just one. Okay? And when we pass two columns, each call of the function will take two arguments, which is the one element from here, one element from there. Okay? So it will be applied on each row. Okay? And the arguments will be taken from the columns that we pass to the apply function. So here is the call, apply name and age to person, comma, birth year. Now this function will take one argument from person and one argument from birth year. That's one row, and then apply it to the second row and the third row and so on. Now tell me what will be the array that is returned from that call now. Array of strings, right? What is the first one? Jim is 35, okay. And the second one? Pam is 32, and so on. Okay, so this is how the array will look like. Jim is 35, Pam is 32, Michael is blah blah blah, Creed is, and so on. Okay? Question?
Can we pass two tables in this array?
Two tables.
Yes, yani for example, if the name was stored in a table T1.
Now the apply function is applied on a table, on one table. If you want to do that, then you have to create a table with two columns, one from each table. Okay? Yes.
And the return name is string age, and the function name and
Now, sorry, where are you talking?
the function name and age.
This one. Yes.
We should put string age at the end in the return value, or we can.
We can try. Let's see what will happen. We get an error. Okay, because that's numeric. You cannot add a numeric to a string. So you have to say string here. So almost every question that comes to your mind about Python, you can try it right away. Okay, and see what will happen. Okay? And you saw, I don't memorize these things. You can just play with it. And I hope that you are really using the textbook. How many of you actually use the textbook so far? Please, the others, use the textbook. It has so many examples. It has code that you can try. Okay? It has even some of the things that I am depending on you to know. Okay? We don't cover everything here in the lecture. There are things in the textbook that you really need to look at. Okay? So let's get back to the slides. So this is the apply with multiple columns. It takes two columns in this case. Column label for first argument and column label for the second argument, and apply to each row. Now here is a nice example of using of doing some computations given a data set. And this is, I think, the first kind of examples that that is related to what we call prediction. So most, if not all of the analysis that we did so far on data sets was exploratory. Okay, we were exploring the data set. Okay, we're trying to understand the relationships between the variables. Here is an example of trying to predict values that are not actually in the original data set. Galton studied some data set extracted from the census data that we saw before. He was interested in trying to predict values over generations. Okay, so we'll see now the data set that he worked on, which has here the file is Galton. It has like 6 or 7 columns. It tries to give you the values of the heights of parents with respect to their children. So you will see here the family number. For each family, you have the father and mother, and these values are the heights of the father and mother in inches. Okay, so that's the height of the father and that's the height of the mother, and this is kind of the average or weighted average of their height. Okay, and then the number of children in this family, and for each child, what is the gender and what's the height of the child. Okay, so that's the data set. Any question about this data set? So you understand now what it is. Now, if I want to see the relationship between the parent height and the children height, I would use the scatter plot. Okay, why not the line plot? Because this is not sequential data, right? It's just observational data. We observed for some families the height of the parents and the children. So we want to look at the relationship between the parent height and the child height, and we get this. Anything that you notice here? Is there any relation between the parent height and the child height? Can you see some pattern here? Is it like random? It's not random, right? It seems to me that it's going on this direction, right? Not perfectly, of course, but it is going in the sense that when the height of the parent increases, the height of the child also increases, right? It's going that way. It's not completely over the entire plot, but it is going that way. Now, that's what we will finish with, is a question, okay? Now, if I told you, or asked you, you are given a parent height, predict what will be the height of the children, of a child of those parents, based on this data. How would you do it? So given this data, if I give you the height of the parents, the mid parent height, tell me what would you predict for the height of the child? Any ideas? Yes?
I would compare the height of the parent, which is.
So let's say that I gave you 68. What would you do?
I would just conduct it for the mid-parent height, which is 68.
But we have okay. Do you have one here? Looking at that plot, is that one family that has the midpoint to be 68? It's more than one family. So then which one we should take? Okay, so that's one idea now. So that's an idea now. That might be good, might not. Okay, so she's suggesting that giving 68, we look at all the values of children here, right? And take the average of them. Okay, that might work. What if I give you 74? Okay, so what would you predict? Okay, so it will fail. Your idea will fail in this case, right? So can we relax it a bit to consider things like that? And instead,
Should we give some ranges?
very good. So, for example, for 68, what kind of range we should look at?
Maybe 65 to 70.
Maybe 65 to 70, but it shouldn't be that wide, right? Maybe it's smaller than this. So maybe 67 to 69, or maybe 67.5, 67.5 and 68.5, something like that. So we look at a range, and then within that range, what should we do? Take the average. Okay. So here is. Forget about the code now. It's not the point of the code. The point of the plot. Okay. So here we take an average around 68. Not average. Sorry. We take a slice around 68, a range, and now we look. What I think you suggested is to look at all of these points, right? And take the average of them, and that would be the predicted value for that input. Okay, if we do that, here is what you will get: 66 point something, and here is when you plot it, you see this yellow point, yellow dot. This is what you predict if you did exactly what you suggested. Okay, taking that range, and getting the average of all of these here. Next time, inshallah, we'll see how we can do that for general input. So how can we automate that? If we give it a value, it will give us the predicted value and how accurate these predictions will be. Any questions? Thank you.